guys, how's it going? Mike coming back at you here with another video on Calculus 1. In the previous video, we began to get into the last major topic for any Calculus 1 course, that is anti-differentiation or indefinite integration. We learned about what finding the antiderivative or the indefinite integral means. We learned some notation and some special mathematical symbols that are used in regards to it. We went through the big properties as well as the big antiderivatives for the types of functions that we've worked with throughout this course, and then we saw some sample problems in regards to finding the antiderivative. In this video, we're going to do just a little bit more practice with those guys, a little bit more practice with finding some more antiderivatives, and then we're going to get into things called initial value problems. So let's kick it off with a little bit of a review of anti-differentiation. I have two problems here. For each of these, you just have to find the indefinite integral or the antiderivative of the given function. Recall that when you find the indefinite integral, your final answer should always include a plus c at the end. So take the time, figure out what the antiderivatives of each of these two functions is going to be. Pause the video now, take the time to figure those out, and once you think you have the answers, press play, and we will see if you are right. Alright, so let's see if you guys got the right answers. Number one, your answer was 5 times the tangent of x plus 1/3 times arctan x, or the inverse tangent of x, minus 11x plus c. The second term in your problem number one, you can pull a factor of 1/3 out of that, and you're left with 1 over 1 plus x squared, which leads us to the arctangent. And the answer to the second problem, -8 times the natural log of the absolute value of x, plus 4/7 times x raised to the power 7/4, plus 7e to the x, plus cosine of x, plus c. So again, this was just a bit of a review from the previous video. Hopefully you got those problems without any trouble. They were pretty straightforward. So, as we said from our previous video, when you find the indefinite integral, you get a family of functions. You get infinitely many functions because of that plus c. C is any constant whatsoever, so you can add or subtract any constant whatsoever onto your function. You could add plus 1, plus 2, plus 3, plus 4, minus 1, minus 2, minus 3, fractions, irrational numbers, weird decimals, things like that. So there's an infinite number of functions that are the antiderivative of a given function. But the problem is sometimes that's not the most helpful. Sometimes we want to know a specific antiderivative of a given function. Sometimes we need to take that whole family of functions and we need to narrow it down to just one. So the question is, what if we want to know a specific antiderivative? How can we figure out when we have this one specific guy? Well, in order to find a specific antiderivative for a given function, we need an extra piece of information. We need what's known as an initial value, which is really just a point that would lie on the graph of our desired antiderivative. A specific x value plugged into this particular function, giving us a specified y value. When you are given a specific point that our desired antiderivative has to satisfy, you take that list of of infinitely many functions, and you automatically take it down to one. There's only going to be one function that will have the general form of the antiderivative that you found, and also goes through that one specified point. So how these problems work is you'll be given f prime of x, and you'll be given a specific value. You'll be told f of a is equal to b. So when you see problems like this, there's a pretty straightforward four-step process that you use to solve these types of problems. And these types of problems, just so you know, are called IVPs. So step one, you are going to find the integral, the indefinite integral, aka the antiderivative, of f prime of x. This is going to get you what the general form of f of x will be like. It's going to give you a general look as to what f of x will be, but it's going to have plus c inside of it. Step two, you're now going to take that extra piece of information, that point that you were given in your problem, and this is where it's going to be used. You're going to take f of x that you found, you're going to substitute a in for x, and you're going to set f of x, that entire function, equal to whatever b is. So you'll have some number equaling something and then a plus c. What you're going to do then is you're just going to solve for c. And then, last step, you're going to rewrite f of x with your c value substituted in. So, compared to just finding the general indefinite integral, this is just a little bit more work that has to be done. Not too much more work, just a few extra little calculations that you have to do. So we'll see how we use this four-step process in a couple sample problems here. So we're going to let f prime of x equal 4x cubed plus cosine x minus 6. We want to find f of x such that f of 0 is equal to 4. So we're given our function f prime. We're also given the point that our function f has to satisfy. This is our x value, and this right here is our y value that we have to hold to. So step one, as we just went through, we're going to find the indefinite integral of f prime of x, and this is going to give me f. So f of x is the integral of f prime of x dx. And when you take the integral of f prime of x, should be pretty clear, pretty easy to find that you get x to the fourth plus sine of x minus 6x plus c. You see we have that plus c part in here, and that's really important. You can't forget about the plus c when you do these problems, because if you leave the plus c out, then you're essentially not setting yourself up to finish off the rest of this problem. You're not finding that one particular antiderivative that will satisfy our given point. So this was step one. We found the general form of f of x. Now we just need to figure out what that c value is. So step two, I'm going to take my a value or my x value, and this is getting substituted in for all the x's. And then I'm going to take my b value here, and I'm going to set it equal to this entire thing with 0 plugged in. And when we do that, we see, okay, f of 0 equals 4, means that 4, my entire function, is equal to, and then you see that we plugged 0 in for x. We get 0 to the fourth plus the sine of 0 minus 6 times 0 plus c. Well, 6 times 0 is 0, 0 to the fourth is 0, and sine of 0 is 0. So we just have c. So in this case, this problem, it was really nice, really easy. We find that c is equal to 4. So we sort of took care of steps 2 and 3 in the same fell swoop for this one particular problem. Last step, rewrite f of x, but just with this c value in here. So I'm just going to replace the c there with a 4, and we come to our final answer. If you haven't seen this symbol used before, just as a quick side note, the 3 dots in a triangular shape, that just means therefore, or thus. So just quick little side note there, not something you have to worry with. So this is our first problem, a pretty nice, pretty straightforward problem, trying to get used to this 4-step process of solving these IVPs. We'll go on to a second problem. F prime of x in this case is 9 over x plus 1 over 1 plus x squared minus pi over 4 plus 10x. And in this case, we want to find f of x such that f of 1 is equal to -6. So again, first step, find the indefinite integral or the antiderivative of f prime of x. Again, shouldn't be too much trouble here to figure out that f of x is going to equal 9 times the natural log of the absolute value of x plus arctan x minus pi over 4x plus 5x squared plus c. Step 2, I'm going to take my a value, substitute it in for the x's. So there, and there. And then I'm going to take my b value and set the entire function of f of x equal to it. And when you do that, f of 1 equaling -6 means that -6 equals 9 times the natural log of 1 plus the arctangent of 1 minus pi over 4 plus 5 plus c. Now, the natural log of 1 is 0, so that whole term is gone. The arctangent of 1 is pi over 4. So pi over 4 minus pi over 4, those things cancel out to 0, plus 5 plus c, so we're just left with 5 plus c. Subtract the 5 from both sides, and we find that c is equal to -11. So that was steps 2 and 3. Finish it off, take the c value, substitute back in to f of x, and write your final function. F of x, 9 times the natural log of the absolute value of x plus arctan x minus pi over 4 times x plus 5x squared minus 11. So a little bit more complicated of a problem here, a little bit more work to do. Perhaps that arctangent of 1 is a little bit of a refresher on inverse trig functions for some of us, but still not too bad. And third and final problem that we have here, let f prime of x equal secant x times tan x minus 3 times e to the x plus 6 over the square root of 1 minus x squared. Find f of x such that f of 0 is equal to 0. So I want you guys to try this problem on your own. Use that 4-step process that we talked about earlier on in this video. Go through those steps on your own. See if you can come up with the correct answer. So pause the video now, try the problem out, and then once you think you have the correct answer, press play, and we'll see if you were right. Okay, so let's see if you came up with the correct answer. First, we need to take the integral of f prime, and and you should have come up with secant x minus 3 times e to the x plus 6 times arcsine x plus c. There is more than one correct answer you could have come up with. I'm going to go through the problem this one particular way, but there is another correct answer that you could have had. The only difference is that instead of having 6 plus the arcsine of x, you could have had minus 6 times the arccosine of x plus c. And that's just going to create a little bit of a difference later on in terms of what your c value is going to be. But I'm going to go through it this way with f of x, including the arcsine. Now I need to take my a and my b values, substitute them in. So f of 0 equaling 0 means that I plug 0 in for x, and I set the entire function equal to 0. The secant of 0 is 1. 3 times e to the 0 is 3. The arcsine of 0 is 0. So I have 1 minus 3 plus c, or negative 2 plus c, and that whole thing is set equal to 0. Pretty straightforward to solve for c then. C is equal to 2. And that means that my specific antiderivative f of x is secant x minus 3 times e to the x plus 6 times the arcsine of x plus 2. So this was a bit of a review on indefinite integration, as well as our practice with initial value problems. If you're going to go on to take higher level math classes, such as differential equations, you are going to be seeing lots of these types of problems. IVPs always show up in the world of differential equations. So if you have any questions or comments, be sure to drop them in the comment section below. Otherwise, take it easy, guys.